Good morning. I'm going over this worksheet with you, San Francisco Microclimates. Now, we had previously in this packet talked about microclimates, and they can be very small, like the underside of a rock, but they can also be small areas within a larger area like San Francisco. So San Francisco, or the Bay Area, has its own climate. But when we look at individual neighborhoods, we can see microclimates, where one neighborhood is different than another. And that's what you see on this map. You see color-coded neighborhoods here, and here's the coding over here, and it describes what the weather's like in those areas. Now, with this map, you can look this up, but all of this area is surrounded by water. San Francisco is totally surrounded by water. It's a peninsula. So 3 sides here are surrounded by water. And then the land goes down south. Winds usually come in off the Pacific, blowing into the city like this. So from the Pacific, blowing into the city, across the city, and towards the East Bay. So you're going to analyze this map here and the weather and answer a few questions based on the conditions in these neighborhoods, okay? And one of the things you got to remember, especially for this last one, is what are the conditions on different parts around the city in the water? So what are conditions over here on the Pacific side compared to conditions over here on the Bay side? They're going to be pretty different. This is open to the ocean, where this one's just open to the bay. On the second page, it's going to show a topographical map. So this shows you where all of the hills and raised areas are. We see this one big area right here, Telegraph Hill, but there's hills all around. There's also some flat areas. Downtown is relatively flat. Ocean Beach over here is relatively flat. But the hills are going to have a big influence. Remember, I said the winds generally come in off of the ocean. So how is this going to affect weather? Well, as winds blow in off the ocean, these hills and stuff are going to act as a barrier. And they're going to kind of force the air to move in different directions in different ways as it's blowing in towards these hills. That can change weather patterns. That can do things like decrease the amount of fog or decrease the amount of winds. Maybe it's a shield for winds, and maybe some areas that don't have as much winds get warmer compared to areas that are cooler, that are right where those winds are. We can also see that some areas of the coast are flat and basically have beaches along here, the north part, along the west part. But then some areas that are right up against, some areas that are right up against the water are all hills and cliffs. And we see that in these regions. Let's see here. And then the last question down here talks about Hunter's Point and the old Candlestick Park, which were right there. And these are kind of anomalies. Most of this area is all warm and sunny because these hills block all that cold fog and wind coming from the ocean. But if you notice here, there's a couple of gaps, right? So if you follow these gaps through here, this acts as like a channel. These raised hills act as like a channel or a funnel for this cold, moist air coming off the Pacific. And Hunter's Point and the old Candlestick Park location would get very high winds, and they could even get fog on days where the surrounding areas were all sunny and relatively little wind. So it presented unique conditions for baseball games and football games held at Candlestick Park. Okay, I hope this gets you started. I've talked about these maps both a little bit. It should be enough for you to answer the following questions. Thank you very much.